Okay, so for some reason, everybody's confused about what exactly is a loop. And things have kind of gone crazy on X. There's now even a new field called loop engineering. This all started with this new tweet from Peter Steinberg. Here is your monthly reminder that you shouldn't be prompting coding agents anymore. You should be designing loops that prompt your agents. Now, Peter is not alone. Boris Cherny from Cloud Code has this to say.
I don't prompt Claude anymore. I have loops that are running. They're the ones that are prompting Claude and kind of figuring out what to do. My job is to write loops.
Okay, so in this video, I want to show you what exactly is a loop and how to write a great one. Also, when not to use them at all, because that's more critical than you think. Okay, so let's define what exactly a loop is and how to set it up. Now, traditionally speaking, you are the bottleneck. You provide a prompt to Agentic system, it generates an output, you evaluate it and provide the next prompt. This is sequential in nature. You are the bottleneck. And unfortunately, this setup doesn't work for long running tasks. Now, the setup or pattern that has emerged for long running tasks is that you as a user set the initial purpose or goal along with a stopping criteria of what the system is supposed to achieve. And then you have the orchestrator, which basically is going to prompt the system based on the current state of the work that is done. Now, if the system reaches the stopping criteria or condition, these can be unit tests or maximum number of iterations or some arbitrary criteria that you have defined, the loop is going to stop. So with this new agentic loop, your job hasn't disappeared. It simply went a level up. Someone still decides what to build and whether it is any good. Even a fully automated loop is still being prompted, and the prompt comes from your initial command and your specs. So prompting does not die, it just moved to the very start. Okay, so is this new or did we just rename something old? This is where my reinventing the wheel worry kicks in, because the loop is not a new idea. And let me put this on a timeline. The oldest version is a while loop with a model in it. In 2022, the React paper described an agent that reasons, acts, reads the results, and repeats. Now, in 2023, AutoGPT gave the loop a goal and let it prompt itself. It got famous for running in circles for hours, burning tokens and shipping nothing. This is what made people call Agent a toy. Now, more recently came the disciplined version, a tiny loop that feeds the same instructions over and over, but resets the context each time so it does not drift. Both Cloud Code and Codex now have a command that runs the loop until a separate check says it's done. So when someone says design loops, the honest question is which loop? And here's the kind of sharpest pushback that I have seen. This is just a cron job with a new name. And they are half right. The scheduling really is a cron. Now, what cron never had is the middle. A cron job runs a fixed script. A loop runs the model that looks at the state, decides the next moves, does it, checks it, and decides whether to keep going. So essentially, a loop is a cron plus a decision maker in the body. Okay, so what does building one looks like? Let's say in Cloud Code, you just type one command, something like /loop on my pull requests. So in this case, you simply write the intent in the stopping condition, but not the actual steps. Now, a serious loop needs a few parts around it. Say worktrees, which is going to have isolated copies of the repo so agents do not collide with each other. Skills, reusable named instructions so the agents is not relearning your conventions every run. And then maybe connectors so it can open a pull request and update a ticket. And verify so the thing writing the code is not grading itself. And then memory on disk, because the model is going to forget between runs, or if it fails, it has something to go back to the previous state. Now, Cron could also recently introduce dynamic workflows. So this is what lets a single loop fan a task out across a lot of agents at once instead of one at a time. It's very powerful, and it is also exactly where the cost can run away from you, which we'll go into in a bit. Now, the most important part of a loop is the verification step, because a loop that simply writes the code and never checks itself is the fastest way to generate confident mistakes and burn through tokens. Now, for a great loop, you want it to be able to run different tests, look through the results, and then have an independent verifier which actually validates the implementation. This feedback mechanism is what makes a great loop. Now, agentic loops are great, but I want to talk about this idea of orchestration tax, because people claim that they're running hundreds or thousands of different agents in parallel. Now, a loop is going to let you start off hundreds of parallel agents, but there's one ceiling that none of this removes, and that are you as a person, because you are the one that is supposed to review, understand, and merge all of the implementations. So the number of loops you can really run is set by your review bandwidth, not the tool. This is really the orchestration tax. I am creating a video on it, so if you are interested in this topic, make sure to subscribe to the channel. Now, more agents does not give you more of you. This is something you actually need to start thinking. Now, even if you are able to push past the ceiling, there's one thing which is going to still break with hundreds of parallel agents, and that is your understanding. Now, if you're running an agentic loop that runs on its own, you just see the final results. And if you look at it all, the gap between what shipped and what you understand is going to grow. So the danger is not that it's going to fail loudly. It is that it's going to succeed quietly in a way you stopped following 300 commits ago. Now, there are two potential outcomes of this. So you can have one person who moves faster on the code they understand, another avoids understanding it at all. Now, the problem is that the loop cannot tell the difference. In both of these cases, you as a user is going to be essentially responsible for what the agent is generating. Now, for smaller projects, it probably works if you don't understand what is going on. But for larger projects and more critical ones, well, somebody has to be responsible. Now, let's talk about that initial prompt, which is the seed of this whole process. The loop runs on a prompt built from your specs. So the first prompt matters more now, not less, because it is no longer one prompt you can correct as you go. It is the seed for hundreds of steps you are not watching. If you leave it vague, the loop does not guess once. It guesses confidently in the same direction over and over again. So if your initial specs, your stopping criteria, your test cases are vaguely defined, these agentic systems are going to make a lot of assumptions. And most of the times, those assumptions are going to be wrong. And this is going to be disastrous, especially for long-running loops. Now, loops are great. However, there's a second cost, which is pretty real, because they can get expensive very quickly. Because every token that is being generated by the agentic loop is going to cost you money. So you need to have a check on when it stops making progress and a hard spending limit. So the romantic version is that you write loops and go to sleep. The honest version is that a lot of your job is making sure they stop. Otherwise, there's going to be a big hole in your wallet, and nobody wants that. Okay, so where exactly does this leave us? If the loop is mostly plumbing and verification is what makes it trustworthy, then the thing that compounds is not the loop, it is the skill it calls. So you want to make sure that you compound the learnings in every iteration of the agentic loop. And for that, you definitely want to create really good skills that the agent can use to learn from its previous mistakes. Okay, so agentic loops are great. However, you need to have solid guardrails, verification criteria, and stopping conditions. But the most important thing that you need to do is you want to make sure that you have really good prompts as seeds with really solid instructions. If you don't do that, you can run these agentic loops for a very long time, but the output is going to be just gibberish and garbage. So if you spend some quality engineering time in the beginning, you're going to get some really good results. Otherwise, well, may the demo gods be with you. Anyways, I hope you found this video useful. Thanks for watching, and as always, see you in the next one.